All right. Howdy, y'all. Is Paul Larson in here? No, Paul? Oh, good. Then I can pretend to be a Texan, because Paul's actually a Texan, and I just live there. But I like it there quite a bit. All right, so my name is Zach Pfeffer, and I'm the Linaro Android platform lead. So it is my job to lead a set of like-minded individuals to put out an Android build across all of our members' single-board computers every month, at the same time every month, that work, are tested, and are easy to use. Our members' boards include the IMX53 from Freescale, and now the IMX6 from Freescale, quad-core. How is that for cool? We've got Panda. We've got, well, we're looking for BeagleBoard volunteers. And BeagleBone volunteers as well. We've got Samsung Origin. And we've got, my favorite, STE Snowball. A fantastic board, actually, especially for embedded systems. But this is not a sales pitch. I am only going through these boards because our experience supporting these boards has led me to this talk. Binary Blobs Attack. I'm working on a movie. Now I have Girl Scout cookies here. Shortbread. Samoas, which they call them caramel delights in Texas. How's that? And Thin Mints, which look different, but they're still delicious. There are 3 boxes of cookies up here. I need 3 volunteers from the audience. You, up here. Who else? I need 2 more. 2 more. This is going to be really fun. Steve Moe, you, come up here. I have just the role for you, too. And Mike Anderson, are you coming to volunteer?
Yeah, sure.
Fantastic. All right, guys. Now, y'all can pick which ones you want after you successfully execute this following thing. So I'm working on a movie. And here's the script. Now, we have 3 people. We've got Philip. We've got, let's see, the FAE of FAST. And we've got, let's see, there's somebody else here too. Vishal. All right, so Steve, you're going to be Vishal. Mike, would you be the FAE of FAST? And Karim, would you be Philip?
Philip, all right.
So you get top billing here. You have the most lines.
Do I actually have to run through this?
Yes, you guys are going to actually act this out.
I will be right back.
No. So okay. So let's go through this, right? Let's do this thing. Let's do this thing. All right.
Okay. On stage. Then,
No, down here. It's a skit. All right, move it along.
Checking my email. Okay, I need to write a message through this blob to the core. Crap, what's wrong? What did you crash? Is that me again?
Yeah, so it's 11 a.m., so now it's 1 p.m. San Jose time and 2:30 a.m. Bangalore time.
Okay. All right. Yeah, I'm not sure. I send the message and boom, the core just stops.
FAE of FAST.
I think that team's in India. I'll send a mail.
Okay.
10 a.m. Bangalore the next day, 8:30 at night San Jose.
I got your
Vishal.
mail. I got your mail, and
That's the only line you have. FAE of FAST.
NDA. We really need to do the. Do you have the NDA? I think I can't really do anything without the NDA. Sorry, mumble.
Vishal.
Right. You need to send the version of the interface you want before using it.
Wait, doesn't have any accent.
I wasn't gonna go there, but
He could be a Vishal without an accent living in Bangalore. That's
Mumble.
cool.
Well, NDA. You really need to get that NDA. Vice President to sign the NDA. With minimum. Only good for a month in NDA.
Vishal.
no, you have the v2.2 of the doc. It's on page 34x-RW-FV-444- close parent of version 2.2.0.1, and you have to check Dora for the new version.
11 p.m. at San Jose time.
See that?
Let me send this before I go to bed.
All right, 8 a.m. San Jose, 9:30 p.m. Bangalore. Philip.
All right. Okay, I sent the version. Crap, what's wrong with the graphics stack? Ding, ding.
All right, so that's okay. So that's the end of the movie. Great, but please don't go away.
Oh, shit.
There's more. All right, so just hang out for 1 second. A word problem for everyone. Father's Day is in 13 days. Not 5, 13, but I don't have 13 fingers. Super Cool, Not Google, and Fast are working on the Father's Day Checks Your Fridge Has Beer phone. It estimates it will need to solve 325 crashes in those 13 days. 2 engineers and 1 FAE can solve 1 crash per day. How many engineers and FAEs does Super Cool, Not Google need to ship their product? Blah, 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 blah. 50 engineers and 25 FAEs. That is an army of people. Well, it's actually kind of like a division of people. Or a brigade. How many? Do we got any army guys in here?
It's a little bit more than a platoon.
Okay, all right, so we need a platoon. So my movie wasn't picked up. Maybe I'll do a web series.
I'm not in.
Here's the web series script. Now, 8 a.m., Philip.
You're not serious, are you?
I'm serious. This is great.
Again? All right.
Yeah, you just have to check your email. Maybe you went to the bathroom before you got to work. That would be good.
All right. Okay, I need to write a message through this blob to the core. Crap, what's wrong? Why did you crash? Looks at the source code. I guess I need to send the version first. Bingo!
Thank you very much. Thank you. So, another word problem. Same thing. Mother's Day is in 13 days. Super Cool, Not Google is working on the Mother's Day Reminds Your Kids to Call phone. It estimates that it will need to solve the same number of problems, but because it has the source to everything, 1 engineer can actually solve 2 crashes per day. How many engineers do I need? 12.5. So, that's great, right? I've saved about, what is that, 2/3 of the resources, and instead of
I just don't want to be the half engineer.
So wow, so Super Cool, Not Google, and Fast can save 12.5 engineers and 25 FAEs. Maybe they can do 2 phones, not just 1. That kind of savings. So anyway, thank you guys very much. Feel free to take your cookies.
All right.
Ooh.
Thin mints. There you go. Anybody want some?
All right. So that's just my. All right. So, having lived through this world for quite some time now, I can honestly say, and I think those who are actually in this industry may hopefully agree with me here, but that time spent on binary blob production, integration, and debugging has eclipsed any other activity in the product cycle. As they say, this is the problem. This is it. This sits at the root of almost every single problem in the device Linux ecosystem. As we saw before with our little skit, what you have is you set up this process where instead of being an interactive engineer like you are, you're now a batch engineer. Work, 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 boom! Send it off into the universe, and the universe gets back to you, right? That's exactly how people used to program big batch machines. Work, 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 get my card deck, give it to the assistant runs through the machine, I get my answer back the next day. We are right back at that. Binary blobs also cause many, many problems, and we'll go through some of those problems here. All right, so let's rant for a little bit. Everybody needs to rant. Everybody needs to complain. Complain, complain, complain. That's all I hear from you guys. Anyway, binary blob scribbling is impossible to debug. What is scribbling on my memory? I don't know. It's in some goop of code that I got from some company that's in some place, and I don't even have a point of contact to talk to them. So what do? I sit there and I go through and I put print statements after print statements and bisect the code and go crazy. Kernel upgrades mean a recompile cycle with the SoC's third-party vendor. What if you don't have a third party? What if the third-party vendor is gone? What if the third-party vendor's guy or gal who did this is now working at the competitor's shop? Binary blobs are unethical. I'm not doing this. OS-independent code is always buggy, slow, and will only be used on the OS it's not meant for. So how do vendors, software vendors, try to handle the expansive universe of operating systems and devices and things like that? Well, they might create operating system independent code, and that operating system independent code is operating system independent, but the person who wrote it is probably thinking in their mind that, oh, this operating system is going to have this, like flat memory, and all the processes are in the same address space. All operating systems do that. If I want one module to communicate with another one, all I have to do is dereference a pointer, and I'm going to be cool, guys. I need debug symbols. How am I supposed to debug this thing? I don't have any debug symbols. My favorite, documentation. Hello. I'm going to kick ARM out of the kernel. I can't track Linus's tip because I'll lose enablement. I can't upgrade to 3.3 because my binary blob is locked to 3.0. I need a JTAG. Write once, run everywhere. Doesn't really work for Java. So how well is that going to work for a driver? So problems. The audio blob is locked to the 3.0 kernel. The graphics blob is locked to the 3.1 kernel. What do you want, graphics or audio? I know. I'll set up 2 units, and I'll make a network pipe between them, and then it'll be great. Hard FP and other toolchain improvements cannot be made, which means your binary blobs are locked in whatever way they were created, whatever way they were produced on whatever GCC or GCC compatible compiler, or even other compiler, and you're just communicating through some shared memory interface weirdness. It doesn't matter. You have no ability to improve these things globally using compiler optimizations, better compilers. The blob producers are always impossible to track down. I swear, it's like when you're debugging this stuff, you practice, it's like the mafia, right? You got to know a guy, you know? Everybody in this room knows a guy or a gal that worked at this company last year that knows the guy who actually produced the blob. And we engineers, we do deal with this all the time. We have this secret little network of the universe that we have that make things actually work, right? You know, USB keys that just happen to get left on desks, that just happen to have a certain thing on it. We have these processes in place. Things fall off the back of a truck all the time. And as I've said before, binary blob integration, because it has gotten so far out of control, has brought us back to batch development. I mean, it was okay back in olden times when, you know, okay, there's a Wi-Fi blob, and, oh, okay, I can write a shim, and, you know, it's kind of self-contained. But then people got these ideas that they could do huge graphic stacks, and the graphic stacks just are instrumented and architected in a way that the use of binary blobs to actually distribute enablement just is breaking everything. And is really, like I've said before, is at the root of most of our problems. Including the ARM problem. So almost everything in the ARM ecosystem has hardware acceleration that makes it work. An ARM SoCs without graphics acceleration are unusable. And if anybody would like to see what that looks like, come talk to me. I will show you a build. You run non-graphics accelerated 1080p Panda, it's really cool. It's really slow. The little mouse goes like this. Doot, 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 doot. Oh, I missed it. Go back. Doot, 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 doot. So this is not a nice to have. This is a must have. You must have these drivers to enable your platform. And as I've said before, these drivers are all locked to older kernels. They're all locked to older user spaces. I mean, it really is a disaster. And then you say, oh, well, Linus, I really need the shim in here because the shim, you know, it talks to this thing. And Linus, rightly so, says, are you frickin' kidding me? I'm not taking that crap. So we're at the ARM problem. So what do? I mean, binary blobs are not going away anytime soon. In fact, they're multiplying. They're getting worse. So we can be open source and we can rail against the system and we can say, yeah, we work with these companies and then they eventually come around, but they don't. They don't come around. That's the whole problem. If they did come around, we would have, our trajectory would be looking less and less binary blobs. But what we see in ARM is that it's exploding. The number of cores in these SoCs is exploding, and every single device manufacturer is saying, oh, binary blob, that's exactly how I want to distribute my code. That's great. So the question is how can we ensure an open, sustainable software ecosystem with that? And let me tell you, when I say open, sustainable software ecosystem, what I mean is I have this phone. And I want to run what I want to run on it. And I want to run my own kernel, and I want to run my own user space, and I want to run not Android. I want to do whatever I want with Android. Android's fun, it's cool, it works. But what if I want to run Ubuntu on this phone? I should be able to do that. What if I want to run Red Hat on this phone? I can do that today with PCs, by and large. And whether UEFI comes in and destroys the universe, maybe this is the only platform I'll be able to run Linux on. It's a possible future. And anyway, I should be able to bring this thing to a conference and plug in a big screen and a keyboard and a mouse and do development on it. I should be able to do that. Not everybody wants to do that, but I don't care about anybody. I care about me. I want to hack on stuff. That is open, sustainable software ecosystem. So what sits really at the core problem? So to change the world, you have to start with where the world is. You can't start with where you want the world because you're never going to get there. So you have to live in the world that you live in. So what is the world that we live in? A proprietary blob is really a blob. It doesn't even really care about what's running in user space and what's running in the kernel. And we've all seen this code. Anytime you've ever seen a device manufacturer give you a matching user space, kernel, and firmware blob that has to be used together, that's what they're doing. It's bleed over. It's super ugly. So, how does Windows deal with this? So I've heard. Well, Windows is a big blob itself. So blobs like to talk to blobs, and when blobs need to talk to blobs in a sustainable, closed software ecosystem, then the big blob tells the little blobs, you must absolutely write to this API. This is non-negotiable. This is the API you will use, and if you don't use it, well, tough. You're not going to be shipping Windows Mobile 7. Now, the market hopefully will decide that nobody wants those phones, but anyway, this is how Windows deals with it. And you especially see this in graphic stacks, right? So what does a typical proprietary stack on Linux look like? Well, there's a vendor proprietary user space proprietary blob. There's an open read write ioctl shim that's kind of part of that, may or may not be closed. There's a little open source right there, little teeny bit. Oh, just run this shim. You want 3D graphics? You totally do. And then you need this big proprietary blob in the middle, and then the Linux kernel sits underneath this. Now this is what it typically looks like. So SoC vendors are in the game to make money. And that's great, actually. It's a free, open market economy. And SoC manufacturers should be able to create whatever they want. And because it's a free and open economy, they think to themselves, okay, well, I don't really have the resources to implement this thing twice, right? Programming a video pipeline is insanely complex and insanely hard to get right. Ditto for graphics. Even Bluetooth and Wi-Fi is no picnic. So the enablement partners look at this and they say, okay, well, we just need to implement this once. So let's pick an operating system that, let's look at the features of an operating system and kind of create something that we kind of know. And well, the big operating system is where we're really going to make our cash. So we really need to make something that's kind of good, but oh, what is this Android stuff? Oh, Android's getting humongous. I have to do something about it. I mean, so that's where we kind of see that's kind of where we're at right now. And so what vendors will do is they essentially try to they try to have their cake and eat it too, and the code that they develop is built in such a way that they can run it on Android and on Windows in the same sort of way. And as we see, like, HTC or other phone manufacturers and SoC vendors, this is the plan. This is the world as it exists now and how it will exist in the foreseeable future. So, what are some things we can actually do? We can actually examine what crosses the operating system barrier. and see what we can do to decouple things. We can rethink memory and power policy and mechanism at the OS boundary. So things like memory allocation drivers, things like that. Actually, so a lot of this comes down to a lot of the complexity we see can actually be seen when you're trying to put together an open video analytics solution. So what does open video analytics look like? Okay, so you've got a video input device, you have a lot of buffers, you're doing analytics, so things are going to have to go through the CPU. There's probably going to be GPU involvement because you're probably video texture streaming to some GPU backend. You're not doing video analytics kind of locally, you're also involving the network. Because you're either asking the cloud for something or you're saying, you know, oh, what is the latest and greatest, like, or let's say I'm looking and I have my cool video, my cool T2 glasses, and I'm like, oh, look at that person. What is their Facebook posts? I mean, that's the world we're actually going to, and it's going to be so cool. But right now, there's really no good open solution for that entire chain. It would take a lot of work to actually get an open video analytic chain put together. And I don't know, given the current environment, whether it would actually be possible in any kind of useful time frame. And it certainly wouldn't be possible to take that and extend that video analytics in any open source sort of way. So if you had your cool Google specs with company X SoC in them, and you wanted to, for example, say, well, I want to hack on these a little bit, that would probably be extremely hard to do. But we'd figure it out, right? We'd figure it out. So we could create official binary box interfaces. So we could kind of take a page out of the Windows playbook and actually say, okay, well, binary blobs are going to exist with us, and we can either put our head in the sand and say, this isn't a problem, this is going to go away. Or we could say, nope, this is the interface. And then once we have an interface, then maybe we can have some sort of control over that interface, right? We can rev that interface. That interface gives people kind of a warm fuzzy. And device manufacturers would probably like having an interface, right? Because it would help their architecture teams kind of figure things out a little bit. We could actually do something kind of cool, depending on your point of view, and totally split devices and the kernel up completely, right? So I kind of look at the kernel. If you look at how a kernel gets developed, there's kind of 3 concentric rings of kernel development, right? There's the core kernel, scheduler, multimedia. There's kind of the middle kernel where like the video and the graphics drivers get enabled, where you're actually hooking into low-level multimedia or low-level allocation routines, which are bad, but that's what you do because you're trying to ship a product and you don't have a good higher-level API. And anyway, you're diddling page tables the whole time, so to get that last ounce of capability out of your chip. And then you have the higher level, right? You have the device drivers and things like that. And I think when you look at it, and why I say things like the memory, like creating actually a memory allocation type device, is that would actually pull a lot of what people do kind of in that middle layer out. And it would actually mean that, for example, like, let's say I want ION. Let's say I want CMA. Let's say, I kind of want to encode, like the boot mem, like contiguous memory. But I'm going to use it, I'm always going to use that in weird ways. I'm always going to, like, ARM has these really cool cache hierarchies and really cool ways of looking at memory and really, really low power. And so I would actually say that you can create all the CMA architecture things you want in the whole wide world, but people will always, always need to get in there and really do a device-specific tune of their contiguous memory space. And right now, what they're going to do is they're going to hack that middle layer of the kernel, and that's going to be icky. So we have a character device, we have block devices, we have network devices, and network devices are this weirdo thing, right? They don't act like character or block necessarily. So maybe we need memory devices, right? You know, if you can't beat them, kick them out. But ultimately, right, we need to, right, sorry, thinking of something else. So here's something, and this is something that my experience at Linaro has actually taught me, that corporations want to make money, right? This whole binary blob thing is ultimately killing them. It's ultimately slowing them down. So let's put it in their terms, right? And we kind of give this song and dance at Linaro all the time, right? If you work with the open source community and you upstream more of your stuff and you kind of try to, your trajectory is more open and your trajectory is more, you know, upstream focused, and you do your development in a way that kind of takes the open source community into account, then you're not going to chop yourself off at the legs, right? You know, you're going to be able to build a sustainable business, and you're going to be able to actually ship products sooner. And that's economic, right? That has nothing to do with any kind of rants or any kind of, you know, open source ideology that proprietary companies either have zero time for or a little bit of time for and give lip service to. But then there are the ones that are actually doing these things, and you see that these companies are, you know, generally regarded as more successful, and their products are actually more stable, and they're better. So there is a little bit of that going on. But what you could say to some of these companies is say, look, I want you to create. I don't want your 60 FPS graphics driver. Keep that, sell that, do whatever you want. I just want some 3D graphics enablement so that I can replace the 3D graphics enablement that's on my phone with something that will generally work. Maybe I'm not going to play Battlefield 3, but I could at least have some fancy graphics and spinny things and some basic graphics support. So what you say is, well, why don't you actually create and sponsor and fund open source teams that can actually take some of the capabilities and create open source versions of these binary blobs? And the payback is that these engineers that are actually going to work on these things are going to be the exact same engineers that you're going to want to pull from and talk to, because they're going to be the enthusiasts. They're really going to push the envelope of that non-proprietary solution. And after doing this for a few cycles, what will probably happen is that the non-proprietary guys are going to be so awesome and what they're going to produce is going to be so cool, and it's already going to be out in the open, that then that becomes the default, right? So there you go. You get in, you get it out the door, and then you keep it out the door, and you execute. Because what do companies respond to better than anything else? Execution. Talk is cheap. But if you can actually do something, create a way forward that makes economic sense, then you can have your cake and you can eat it too. And of course, we can always reverse engineer stuff. This becomes very hard when you're talking about firmware that lives on some core out in the ether of the chip, but it's all possible. And people have been known to do this. So you have the new R-Molly open source solution that is getting developed, and that's good, you know. But the thing is that we shouldn't have to go down this route, right? It shouldn't have to be that conflict. We should actually say, look, you guys are getting a lot of value out of Linux, and you guys are shipping devices in a variety and method that you would have never been able to do with this proprietary ecosystem that you guys used to have. And we know you want to be successful, and we know you don't want to get sued, because the elephant in the room is that really the device manufacturers don't release these because of the legal implications of doing so. And so maybe things like creating an open lawyering organization that can handle that sort of thing, right? Outside the box thinking. It's not all just a technical issue. In fact, most of this, when, you know, we're engineers, so we say, well, to hell with you, I can do whatever I want, I'll just be smarter than you. But if you can get, you know, kind of the outer, you know, other people involved in the open source world, then they can help you. And lawyers are cool. There are lawyers who care about open source. So, feel free to send me questions, rants, anything you'd like to my email address. I'm always PfefferZ on #Linaro-Android on irc.freenode.net. And you can always hit me on G+. It's Zach Pfeffer, not the soccer player. Because there's a cool soccer player named Zach Pfeffer. Who knew? What? No, I love soccer. I'm not that guy. He's like the new Beckham, man. No, seriously, he's like 16. He's playing pro soccer. And I'm like, wow, that's really cool. He's going to grow up and he's going to be Beckham, and like my name will mean nothing anymore. It's like going to be the guys who are like, who's the guy that plays the saxophone thingy? You know who I'm talking about. Kenny G, right? Like, there was some guy named Kenny G, and he's like, man, Kenny G guy. I'm not that guy. I'm my own guy, you know? I hate saxophone music. But I actually like soccer. So anyway, I'd like to open it up now for questions, comments, ideas, spitballing. Is this crazy to have tiger teams of open source engineers go on to companies and actually help them out? Is it crazy to create a open lawyering organization to actually address these things head on and ensure the open ecosystem? Do you think that if we just sit by and do nothing, that things will work themselves out? Because I don't think that is going to happen. Yes, sir. Right.
And the lawyers that I've spoken to eventually can come around to understanding the market issues, but Lord, it's a long road.
It is a long road, but it doesn't mean that you can't start going down it, right? How do you eat an elephant? One bite at a time. And, you know, look at IBM, right? IBM got religion. They put patents into the open, and that has I think that has actually changed the face of the universe in a lot of ways. Exactly. That's exactly right. That's exactly right. And so if binary blobs are the root issue, that's the root issue of the binary blob problem, which is not an engineering problem. Yeah. You know, companies go after other companies for a variety of reasons, most of which are competitive in nature, right? Look at Apple right now. Apple is suing everyone. And they're going to do more of it because you know what? They've lost Steve Jobs. And Steve Jobs was the guy who was the product guy. He was the focus, right? Now it's just going to be, Apple is just going to become this, you know, let's just make money and blah, 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 blah. So what I don't know the future, but what I do know is that when your strong leadership leaves, your company starts to go down the tank, right? Look at Hewlett-Packard. Are you kidding me? You know? That company's about to explode. So, yeah, I mean, companies, taking it back, sorry, rant. Taking it back to your original question. protection licenses are all, they don't matter, right? People sue other people with very little to go off of, but they can still tie them up in legal fees, and if your lawyers aren't bigger than their lawyers, then, you can sink a really good idea just through the process, right? And thank God, look, we just got through SCO suing IBM for $1 billion, right? I mean, that took 10 years to work itself out, and they had no case. So thank God it was IBM, right? Thank God it wasn't the other way around, or else SCO would have just folded up and closed up shop. Like, IBM's going after me? I'm done. I'm not going to do that. Any other questions? Yes, sir. I like this. No, please. Yes. There's precedent of people getting sued over 3 lines. I mean, it happens, right? Depending on what those 3 lines of code are, right? Those could be the magic lines of code that get, look at it this way, right? There's a really, everybody's trying to get to that low power video playback, right? Let's say those 3 lines of code are the magic bullet to low power video playback. That's a big target. And if that's not done in a specific way, but you have companies like IBM and Intel and these companies that are open source minded and look into the future and say, okay, we're better to be open than we are to be closed. I think the thing is ultimately is that it's okay to, it's kind of like, yeah, we're going to have these proprietary solutions and this is kind of exist with us. So let's let the open source community set the agenda. It's not stop reacting to these events and actually be proactive and get in front of the issue. Say, this is what we're going to do. This is how we want you guys to interact with us. So how much time do we have left? Totally 5 minutes? All right, so is there any more questions? Yes, sir. Yes.
One of the problems that the lawyers have is if you display the source for a driver, they think that they're going to be sued for patent infringement.
Right.
Microsoft just bought Novell's patent library.
Right.
It's not an engineering issue.
Mm-hmm.
You're not going to send engineers in to help a company open source their stuff, but they could do it if they can address the issues of liability, patent,
Right.
trade secret that they want to protect.
So the answer to your question is there's some talk of, very, very preliminary talk of patent pools and actually creating, having companies actually agree to say, we're going to put our patents in, you're going to put your patents in, right, and we're not going to sue each other. And I think if you get enough of those organizations around and they actually come together in an association like that, then yeah, you'll still have outside trolls that come in and try to get their $1 million and get their licensing fee, but it's always easier to confront an issue when you're united as opposed to when you're warring together. Yes, sir.
Yeah, I think common interface standards could help solve the problem too. So like
Yeah.
voice control is common, so you can open source that. You don't need to have proprietary.
Right. And I mean, it's not all doom and gloom, right? I mean, just Intel after 20, I don't mean it like that. What I mean, because you're from Intel, but so it just popped into my head. But I mean PC space, right? PC space has gotten more open, right? Now the PC space has something that the ARM space probably will never have, which is standardization. There's a lot of standardization in the PC space. ARM is way more loose than that. But I actually think that this video analytic based like hardware device may actually become the ARM standard. And so the thing is okay, if we can get there in a hackable way, then I think we're doing the right thing. Because anything else that comes after that, you know, I don't know what you do after video analytics. Yes? So, you got it. I'm way ahead of you on that one. So, Linaro has actually worked this issue out. So, oh yeah, that's Paul's email. Anyway, don't read that. No, there's nothing there. No, Paul Sokolowski, man, this guy's great. He runs our Linaro backend. So I won't show this because we don't have the time, but you know, you had said like where can you actually go to like work, and you know we're going to create a lot of different things, right? We're going to have Yocto, we're going to have Linaro, we're going to have a lot of different solutions to this problem. What Linaro does, so my goal with the Linaro Android platform team is to create pretty much the standard stock Android experience across all of these boards. So do I want to use Yocto? No. I want to use repo. I want to use whatever AOSP pushes down. What I want to do is make sure that all of these boards, which they're all SoC boards, they have a set of features, and the SoCs have a set of features. What I want to make sure is that Linaro can actually enable every single one of those features in whatever way we can do it. And right now what we have is we have a variety of binary blobs, but the thing is we've integrated it. And the thing that we're doing, because we are completely upstream focused, so no long-term stable here, folks. You want Panda board on the 3.3 kernel with graphics and hardware decode? You got it. We've got that build, and I'll show you that build today. And it works, and it's great. And we've busted that nut. We've actually busted out how to do Android in an upstream fashion. It's taken us a year. It's taken us yelling at our members for hours and hours and hours and cajoling and then negotiating, and then they say, wait a second, you guys are actually onto something here. And you guys' enablement is a good thing. And we try to bring the units together. What's that? But so anyway, the goal is, right, you need hardware enablement. Hardware enablement is extremely hard to do. Linaro is doing that work. We are shoveling for everyone so that everybody can come here. You can either use Linaro, you can take what Linaro's had. We're totally open, right? Anybody can take these builds, anybody can take our manifests. But what we really aim for is if you look at that feature sheet and you say SoCX has a video decode unit, you can come to Linaro and it will work. So that's where we're at, because look, there is no x86 for ARM. There is no reference platform, but you still got to hack on something. So most people today are hacking on these phones, but we have boards that are $100 that have HDMI and keyboards and Wi-Fi and Ethernet and gyroscopes and anything else, and you can use those boards today to develop on, and they work. Because when it all comes down to it, I believe in if you take care of the little stuff, the big stuff will take care of itself, and the little stuff is making Wi-Fi work on the Snowball board. And that's what we do every single month without fail. So, and we document it too. You want to figure out what our enablement is? It's right there. We do an entire QA process. We have a whole CI loop. You know, Linaro is, you know, to talk about our CI loop just for a second, I mean, we're finding kernel bugs. Because every single new kernel that comes in, we actually run it through a regression. So, you know, we're trying to test the kernel in a way that, you know, a more proprietary organization would actually do it. And we're focusing on the little things, test cases, regressions, enablement. And in doing that, then we're able to handle the bigger stuff because now we have a reference platform that people in PC and other places have had for years. So first we had to invent the platform, and now we're improving it. And binary blobs are at the root of what our real issue is. So that's all I've got. Thank you guys very much. Appreciate it. Feel free to grab me, and feel free if you want to see what Linaro or how to use it, or you want to go home with an SD card for your Panda board or your Snowball or your Origin or your IMX. Come get me. We'll program it up together. I'll show you how to use it, and you can go out the door with it.